All right, everyone, let's take a look at page 12 together here. So in this one, we've got a conductive rod and a conductive strip, and these two are going to come in contact. They actually touch each other. That's important, right? Because that means this is going to be charging by contact. That's what we're looking at here. So let's dive in and start drawing the diagrams for each one. So the conductive rod has a charge of positive 6. They all have 10 atoms, so we know that we are going to have 10 protons in each one. So let's just start with that. Draw our 10 protons, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And those don't move. So let's go ahead and just copy and paste them over to the other diagram, because protons do not move. So there we go. All right, good. Now we've got a charge of positive 6, which means because we know we've got our 10 atoms, we've got 10 protons, but we've only got 4 electrons. So let's go ahead and give it 4 electrons. Let's make them a different color so it's easier to see. Maybe there. Okay. It is a conductor, so we'll spread them out. So let's go like 1 here, 2, 3, 4. And this guy's neutral, so we'll give each one an electron. And all the ones that have 1 proton and 1 electron, we circle. So we'll circle all of those. Circle these guys. Okay. Now, because they touch, what's going to happen is they are going to split the charge. So in charging by contact, the charge gets split. So we had a charge of positive 6. So now we're going to have charges of positive 3 and positive 3. And how do we get a charge of positive 3? Well, if we have 10 atoms, we have 10 protons. So 10 atoms, 10 protons. Let's make this look a little nicer. Okay, there we go. And so to have a charge of positive 3 means we have 7 electrons. 7 electrons. So let's go ahead and add 7 electrons to each one. Now, even though they touched at the stars, this is where they touched, these are conductors, so those 7 electrons will spread out. So let's spread them out. We'll go like 1, 2, 3, 4, 5, 6, 7. Maybe here. Yeah. And then we'll circle those. And, oops. Same thing over here. We'll give 7 electrons over here, spread them out. 1, 2, 3, 4, 5, 6, 7. Let's see if we can spread that one out a little more. We'll do this. There we go. All right, so circle the ones that are neutral, like so. And then we'll zoom out so you can all see nicely. All right. There we go. So we can see that each object now is a charge of positive 3. So remember the 3 things we talk about in our explanations. We talk about what did electrons do? Why did the electrons do that? And then we got to answer the claim. So let's start by talking about what electrons did. So electrons went from the strip to the rod because the rod, when they came in contact, these 10 electrons got spread out. So 3 of them went to the rod, and so we're left with 7. So the electrons transferred from the strip to the rod. So electrons transferred from strip to the rod. Okay. Now we got to explain why they did that. So remember, it's almost always opposites attract or likes repel. And in this case, it is likes repel. And so these electrons are attracted to the exposed protons over in the rod. And so they're attracted. So that's why they move over. So we're going to say why they did that. And we'll say the electrons in the strip were attracted to the exposed protons in the rod. So it is rod, yeah. There we go. Now we just need to answer the claim. The claim is after the conductive metal rod and strip touch, the two objects will, in this case, because they are both positively charged, they're going to repel each other because likes repel. So since both are positively charged, they will repel. And there you go. That is the solution to question on page 12. Thank you for watching. Go ahead and correct anything that you need to correct. Again, we talked about what the electrons did, we talked about why the electrons did that, and then we answered the claim. All right, great.